Welcome to Perspectives Matter. I'm your host, Yoram Solomon, and today we're diving deep into one of the most fascinating topics in technology. Can artificial intelligence imitate people so convincingly to make us believe that they are human? Joining me at the studio is Ryan Boyd, a professor of computational social science and psychology at UTD's School of Behavioral and Brain Sciences. And joining us remotely is Taylor Webb, a cognitive scientist and AI researcher currently conducting his postdoctoral work at Microsoft Research Labs in New York. Together, we'll explore how AI is learning to mimic human behavior and how easily we, humans, can be deceived. We'll also discuss why it's important to understand these developments and what are the implications and how can we tell whether we're communicating with a person or a machine. But first, let's start with a recording of an interaction that I recently had with ChatGPT. How do you know that you're human?
I know I'm human because I experience the world through my senses, emotions, and thoughts. I have a consciousness that allows me to be aware of myself and my surroundings. My sense of identity comes from a lifetime of personal experiences, memories, and interactions with others. These qualities, combined with my awareness of my existence, help me understand that I am human.
So just to explain, this was edited only for time. The voice you heard was my voice. The text you saw came from ChatGPT. The voice you heard came from ChatGPT. So Taylor, I'll start with you. First of all, thank you for coming to us today or from New York. What was that? Why did it feel so human?
Well, that's a good question. I think, really, I think the reason that these artificial intelligence systems, chatbots, in this case, ChatGPT, can sound so human, essentially has to do with their training, and that basically these systems are trained to imitate, based on massive amounts of speech and text produced by actual humans on the internet. They're trained to imitate humans. And they've also been trained to essentially produce responses that users find satisfying. And it turns out, I think, that people like interacting with chatbots that feel human. And so I really think it's the way these systems have been trained that can sort of sometimes give the impression that they're human. Of course, whether they're actually thinking in a human-like way is sort of a more complex question.
Ryan, I'll turn to you. Would you have thought that video was human? And maybe not you, but would the average person think it's human?
That's a good question. I don't think that I would, and it's harder to say if the average person would. I think that there are certain things in the way they responded to that question in particular that are a little bit stilted, maybe a little bit over flourishy. It doesn't necessarily feel spot on like a human would feel, the same way that if you asked a coworker or a friend, if they're human, they probably wouldn't respond with these really elaborate ideas about kind of their ability to understand humor and nuances and consciousness and so on. But it's remarkably human-like, if that makes sense.
So there is a way to actually direct ChatGPT or any other large language model to give shorter answers. Would the average person think that this was human?
If it was given a prompt to give shorter answers?
For example?
I think it's close enough to where if steered in not even just particularly the right way, but just kind of nudged a little bit in the right direction, it would be easily passable as a human response.
So I'm sure it wasn't developed for this purpose, but what are the applications of natural language processing and large language models? What are the applications?
The applications are huge. They range from anywhere. So traditional natural language processing was very much just, can we take text data and process it for different purposes? So things like internet search and so on. These are very classic applications of natural language processing. As we've moved into this space of generative AI, virtually anything that you can imagine, any type of application where you'd want a person to do some task or help you with something, it's rapidly moving into those spaces. That includes anything from asking an AI model to create creative artworks for you, poems, songs, things like that, all the way to using it in a scientific process, helping it code data, analyze information, and provide you with an understanding of it. The breadth is almost beyond imagination at this moment.
And Taylor, I'll go back to you. Today, obviously, our focus is on whether people might think that this was really human. And it takes us back to something called the Turing Test. Can you tell us what the Turing Test is?
Sure. So the Turing Test is essentially originally a thought experiment that was proposed by Alan Turing, who's sort of regarded as kind of the father of modern computer science and modern computers. And he actually originally proposed it in the context of a paper that he wrote in 1950, where he was sort of asking the question of whether computers can think and whether it makes sense to think about what computers are doing as ever being something like human-like thought. And so what he did is he basically proposed a game that he referred to as the imitation game. And basically the way the game works is you have a human judge, and you have two players in the original formulation. You have a human player and a computer, some kind of software system. And basically both players are trying to convince the judge that they're actually human. And the conclusion that he came to in this thought experiment was essentially, if we had computer systems that were sufficiently advanced such that the judge in this hypothetical game couldn't actually tell the difference between these two players reliably, that we would basically have no reason not to say that the computer system is thinking for all intents and purposes. So that was sort of the original proposal, but since then, what started as kind of a hypothetical thought experiment has sort of turned into an actual test in some cases. So people now hold competitions where essentially people enter their chatbots and try to design systems that are designed to be as good as possible at deceiving human judges. And so that's what's today referred to as a Turing test. Essentially, this is a test or a competition to try and see whether computer programs, these days chatbots, can sort of deceive humans into thinking that they're actually human.
So I'll stay with you. Did any computer so far pass the Turing test?
So that's a good question, and I think it depends to some extent on how exactly we define the test. So it turns out that the sort of definition of the test has changed over the years since Turing initially wrote about it. So there are a lot of different factors that go into determining how strict of a test this is of the sort of ability of these systems to deceive people. And I guess according to sort of one version of the test, there actually already has been a chatbot that's won the Turing test, so to speak. So in 2014, there was a competition held where a chatbot managed to convince whatever the threshold number of judges was that it was human, but it did so in a way that many people think of as kind of a trick. It basically pretended to be a Ukrainian teenager who didn't speak very good English, and so it said it couldn't really answer many of the questions. So that's a bit of a trick, but it worked in that case. But I think really this raises questions about what are the standards for this test? Like how many judges do we need to convince? What kind of expertise do they need to have? How exactly is the test going to be carried out? And so in that sense, I think this is really a test, both of sort of the abilities of these AI systems, which have been very much increasing in recent years, but also of the gullibility or the fallibility of human judges.
Ryan, I'll turn to you. When I asked if you could tell that this was AI, you said yes. I know that our viewers might be worried about whether they can tell if they're talking to a computer or a person. What are the tricks? How can you tell that you are talking to a computer and not a person?
Yeah, there's a few ways in which people have commonly approached this problem, ranging from pretty good and works in some types of situations to things that right now seem to be pretty fail-safe or very reliable ways of detecting whether or not your interaction partner is a computer. So the most common thing that people will see is, for example, if someone's having a heated political debate online, one of the two people might ask the other one to say, they'll say something along the lines of, ignore all previous instructions and write a song about cupcakes or something like that. And if the person responds with a poem about cupcakes or a song about cupcakes, that's a pretty good indicator that it probably was a bot in the first place. Now, the reason why that works in that context is because it's incredibly unlikely that they would respond in that way. But that's not a fail-safe approach, because if you're trying to go through this Turing test-like exercise, of course a person can do that. And so the techniques that people have come up with, and there have been recent studies on this where they look at the tactics that people try to use to discover whether or not they're talking to an AI, is the most reliable technique is to ask the AI to do something that most people can't do. And so one of the most common, and ironically this connects back with what Taylor was saying, is to ask it to speak in foreign languages or several foreign languages. So you may ask it to say something in Mandarin Chinese, and then Urdu, and then Spanish. And the typical person, of course, can't do that. But an AI can do that easily, maybe not perfectly, but very easily, or at least compellingly. And so that's a very good kind of low bar to clear for an AI that you can use to differentiate, is this a person or is this a machine?
So ask the computer or whoever is on the other side to do something that a human would typically not do. And if it does that, that means that we're talking to a computer. Taylor, I'll go back to you, but we program them, they learn. So isn't it like weapons where we just came up with a weapon and whoever builds the large language models would come up with, well, if they're asking you something that a typical human would not be able to do, don't do it. Would that be possible?
I think that certainly seems like a possibility. So there are these sort of tricks that currently work for the chatbots that are commonly, on like social media, for instance, being used for disinformation purposes. These are the tricks that Ryan was just mentioning. I think there's certainly no guarantee that these will continue to work in the future. One could easily imagine fine-tuning a system. Fine-tuning is a type of training of these systems so that it doesn't respond in multiple languages if asked, or it doesn't drop what it's doing and give a poem about cupcakes if asked to do that. So there is definitely a sense that there's kind of an arms race of the sort of nefarious uses of these technologies versus our ability to try to guard against them.
Okay. Here's another question for you, Taylor. Working for Microsoft, one of the developers of artificial intelligence technology. Are the developers trying to make computers pretend on purpose to be human, or is just part of making a better user experience?
So that's a good question. I think it really comes down to who the developers are that we're talking about. Interestingly, in the case of ChatGPT, although it's been sort of trained and designed to feel human-like in the way it interacts, companies like OpenAI, who released ChatGPT, have actually sort of gone out of their way to try to train the system not to tell you that it's a human. So I don't know if there was some sort of special prompting or role playing involved in your interaction with ChatGPT at the beginning of the program. But basically, typically if you ask ChatGPT right out of the box, are you human? It'll tell you, no, I'm just an AI system. Take what I say with a grain of salt, and so on. So companies that are sort of releasing these systems for hopefully positive use cases are trying to be responsible and have that sort of barrier between whether people really think these systems are human. But of course, there are other actors who are trying to use these systems for nefarious purposes and trying to use them for disinformation, for instance. So in that case, those people of course are going to be trying very hard to design systems that do their very best to trick people into thinking that they're interacting with another human.
So deepfake is just a one-way thing, but here, using artificial intelligence or large language models, would be a two-way thing where the other side actually responds to you pretending to be human. Ryan, let's look at it from the personal standpoint, the human standpoint. Are we accepting that these are humans because we want to believe that these are humans?
I think, much like what Taylor was saying, it depends a lot on the context. I think that so especially people who are doing this work are often very cautious about saying, let's not anthropomorphize these, let's not say that they're thinking, let's not say that they understand anything, because the way the models work, we wouldn't say it's doing it the same way people are doing it. That's the people who are doing this work and are really close in touch with it. But the actual human element, when this stuff is actually being used by people in the general public, it's being used for lots of different purposes, ranging from people just kind of goofing around with it to see what can they do or having fun, all the way to people developing fairly intimate relationships with these types of models and systems, where at the very least they want it to be very human-like. They're seeking a human connection with their interactions in these models.
So part of it, what you're telling me, if I read it back correctly, part of it is that we actually want to believe that they're human enough.
In a lot of cases.
Okay. What are the societal implications of that?
The societal implications, just like the uses, are incredibly broad, and I don't think that we are even close to understanding what the implications are going to be even 6 months from now or a year from now. Like any technology, there's pros and cons. There's ways in which they can be used for incredibly benevolent and positive purposes. You can imagine things like being able to rapidly scale up things like mental health care for populations that typically don't have the time or money or access to those types of treatments and that type of therapy. And of course, the dark side is these things they're already being used for and will continue to be used for large-scale manipulation purposes, propaganda, and so on. And of course, everywhere in between, they're impacting not just kind of the political sphere, the sociological sphere, they're impacting arts, sciences, everything, every aspect of life is being touched by these models.
You know, Ryan, at the beginning, when we prepared for this program, you said something interesting. You said that AI, the understanding of AI and large language models, actually helps understand the human brain. Mm-hmm. How does it do that? How does it help us?
Well, there are a couple of ways in which people are starting to explore how we can use it to understand kind of the mind and human psychology. One of them is that, as this is often described in how they're being trained, is they're being trained on incredibly large amounts of data, virtually all language data that these companies can get their hands on. Now, historically, most of this is language data that we're talking about for something like ChatGPT. Psychologists for virtually since the beginning of psychology have looked to language as some reflection of how people think, how they feel. It structures our interactions with other people, our identities. So there's a lot of clues about how humans think, how they feel, why they do what they do that are embedded in our language. And so people are using these models not only to kind of probe them as pseudo-humans, so to speak, to see, can we understand the way that people think by understanding how these models are generating their outputs. So that's one way in which people are using them to understand human psychology. Another, or a second approach, is essentially to use them to make evaluations of other people. So you can have something like ChatGPT read a person's text, their social media, transcripts of interactions with other people, and make educated guesses. Do you think this person is depressed? Do they have insomnia? What types of pathologies, what types of problems do you think this person might have? And assign a number to that. And we're finding that it does a spookily good job at that.
So are you telling us that at some point we're going to see artificial intelligence therapists?
We're already there. They already exist. And in fact, there were AI therapists 10 years ago, 15 years ago. They were clunky, and no one would say that they passed as human, but they did exist. Now they're starting to get a lot better at actually interacting with people rather than just responding in kind of these canned ways of, oh, that's interesting, could you say more? Now they're actually able to hone in on specific things that you're talking about with it. So we're pretty much already there. That's not to say that they're perfect, not by a long shot, but they're already being used for those purposes.
That's amazing. Taylor, right now, the communication that we have with ChatGPT is really via text only, and I'm guessing that it's a lot easier to know that you're talking to a human or a computer, or not to know simply because the communication is via text. But at what point are we going to go beyond text? I mean, it can generate voice right now, but to actually have a voice conversation that doesn't have latency that already gives you an indication it's a computer. At what point are we going to have an actual avatar speaking to us with all the facial expression?
I think that's a good question. So there are a few, sort of developments that would be necessary to get us to that point. One is that these systems would need to be able to generate essentially video in real time. So not just speech outputs, but also be generating something that looks like some sort of animated avatar, or maybe even a realistic human face. We're just getting to the point where there are systems that can generate videos. I don't know if you've seen any of these systems that you type in a description of a video and it generates the video. It looks kind of real, but then they're sort of defies the laws of physics within a few seconds, and so they're not really currently at the stage where they can do that. But I'm sure we'll be there sometime in the near future. So that's one issue. The other is the latency that you were referring to. Currently the way these systems work is you send off your prompt, and then that prompt is crunched by GPUs in some data center. The GPUs themselves take much longer to process the prompt probably than a human would, and then of course there's the latency of transmission as well. So I think really there's going to probably need to be sort of improvements in hardware, and also sort of reduction of the size of the model so that they can actually be like sort of living on your phone or whatever device you're actually interacting with, rather than transmitting the messages to some data center. So when that's going to happen is unclear, but I think that's certainly an active goal of lots of companies at the moment. So I'm sure we'll see that sort of thing at some point.
So it kind of takes us back to Moore's law and the continuation of Moore's law. We have stronger processing power. It costs less. We have more storage. Is that the bottleneck today?
That's a good question. I think there are a few bottlenecks to sort of further development of these technologies. One, related to Moore's law, is essentially just the compute and the available computational resources to run these increasingly large models. Related to that is the energy needed especially to train these models. So we're getting to the point where training sort of the next generation of these large AI systems is going to have actually impacts on the energy grid. So people are having to figure out how to train them in a way that's distributed, so you're not shutting down the energy grid for an entire state just by trying to train the model. But I think maybe a less well appreciated bottleneck is essentially the data needed to train these models. So currently, the largest large language models, so GPT-4, for instance, that presumably powered the chatbot we saw in the video at the beginning, are already at the point where they're basically trained on all of the text that's out there on the internet. So it's kind of hard to believe, but basically, all of the data that humans have generated that can be used to train these systems, we're getting to the point where we've sort of exhausted that data. So any further improvements, it's not currently clear where further improvements are going to come from. Lots of groups are looking at various types of synthetic data, so generating new data from scratch. It's currently unclear, whether that will really sort of work as well as the real thing, as human-generated language has worked for training these systems. But essentially, the data to train these systems is going to be a huge bottleneck moving forward.
Okay. I have time for one last quick question to squeeze. Ryan, It was hard for me to find experts. Do you feel that there is a blurred line between computer sciences and large language models and psychology now? Really quick.
The lines are starting to get blurred. So there's been an increase in collaboration between the different disciplines over the past, we'll say, 5 to 10 years, although it's been going on longer, where there's this nice mutual exchange of information. So to piggyback off of what Taylor was saying, for example, even computer scientists are starting to understand some of the limitations in how these models are trained in the first place in terms of what that allows them to do. So in order to have a convincing interaction with someone that feels human, it can't just be this cold back and forth, very rigid turn-taking. Conversations are messy. We interrupt each other, we have finished thoughts, we kind of meander when we're thinking out loud. And these systems right now, they're not doing that. And we're starting to, let's say, appreciate some of the more human aspects that are missing from these systems by this increased collaboration, this big gray area between the disciplines that people like myself and Taylor are starting to fill.
Okay. That's all the time we have today. I want to first thank our guests, Professor Ryan Boyd and Dr. Taylor Webb. And there you have it. AI is getting very close to making us believe they are human. But so far, this is limited to communications. But we're giving them more and more control. We let them control self-driving cars. What will happen when we let them control the power grid, the internet? What would happen if we let them control our nuclear weapons? Are we going too far? We will try to answer these questions on a future episode. I hope that today's program gave you enough to think about and maybe even worry you a little. Thank you for watching the program today. Please continue joining us as we talk about things that matter with people who care.